I am Zaki. You've probably seen me already. So this talk is like sort of a appeal to people who are protocol developers mostly, but a little bit of sort of philosophy of protocol design, and generally like my thoughts about like what constitutes a full node and the sort of changing definition. So I've been working on building blockchain like protocols for 10 years. I've written a lot of, I've contributed and worked a lot on different layer ones. That's basically my background. And my general thought is that, okay, so we started out with this like piece of software that didn't come from essentially anyone in the present community, Bitcoin. And Bitcoin worked a certain way. And every blockchain network that has been created since has been in some ways inspired by the Bitcoin full node, by like that original Bitcoin software. And its core property of the Bitcoin software was you have this notion of a full node, and in the original Bitcoin sort of concept, every full node was a miner. So you had this whole network of miners. Everyone was connected to each other in an ad hoc basis, so there were no like special roles. It's just network of nodes. You had this flat topology, and that is how we've sort of imagined every blockchain since then. But this hasn't been a true description of blockchains, basically for as long as I've been involved in them. So instead, there have been parallel networks, like sidecar pieces of software, specialized nodes everywhere. Like we couldn't use blockchains today if none of this existed. So blockchains would be completely unusable. That's been true since, since like 2013, 2014, right? You've had, like, Bitcoin has something called the fiber network. The fiber network does fast block propagation between, with a completely different block propagation algorithm between mining pools. There's mining pool software, which is incredibly important for the operation of Bitcoin. You have things like MEV boosts and flash bots. So what this has emerged is an enormous difference has happened between the actual protocol, like the protocol that our users use, and what's in the full node software. And that makes it very, very difficult for anyone to like reason about, maintain these entire systems. So just like to kind of, so Bitcoin is actually like a pool-driven block propagation system. There's no widely distributed MEV tooling, but like mining pools are in charge. The like network that actually matters is the network between mining pools. The transaction propagation system is how mining pools end up ingesting transaction. The de facto Ethereum network is a network that has a consensus system and a peer-to-peer layer, and a mempool that does not actually matter because MEV boost builds most actual blocks. And there's an entirely other network between block producers and relayers and block builders that is essential to the functioning of the system and is potentially vulnerable to exploits, but isn't part of the core protocol. And then in Cosmos, we have this thing called protocol-owned builders, where validators build and check blocks together with consensus-enforced rules to do value extraction. And it's actually cool because in Cosmos, we do seem to be moving to a large extent towards more parts of it, the software being in like the core binary, which is good and more maintainable, but also like sort of represents better the expanding complex. But we've had a lot of problems because our full node software was never designed to do this. So like questions I would ask is like, why do we write blockchains that have mempools at all? It's really unclear why we do this. Bitcoin was basically designed with this idea that like any node in the network could, will once in a while produce a block, so we need to disseminate by flooding transactions everywhere. We have, we really care about the like resilience, censorship resistance, and self-repair properties of P2P networks. But it's probably the most poorly tested and specified property of any piece of blockchain software. Like you have all of these papers that clearly specify like the consensus algorithm, the rules, the attacks, No comparable sort of material exists for the P2P networks. So yes, why don't protocol nets put these overlay networks in the core protocol? So the networking layer is the least expressive part of the stack. We have like these crazy expressive smart contract languages. We have the ability to we have very complex and sophisticated consensus protocols, but we don't really have much expressiveness in this part of the stack. Every blockchain team reinvents the wheel. They run into things that they can't build with like the existing software, so they'll slap on an overlay network and add it to the nodes as the way things. And sometimes those will have centralized parts, like in Cosmos when we have Skip, and Skip has become sort of canonicalized into some of the Cosmos networks, but it's not something people think about as part of the Cosmos protocol. So yes, we have these Frankenstein blockchains. Ismail is talking about how Celestia has this Frankenstein P2P network, which is part Tendermint P2P, part lib P2P, and people are always building these things with other custom components. So I do think that PBS is just largely a good thing, and the formalization of PBS, because it's driving more innovation and attention towards these areas. It's driving, I think, and forcing the P2P engineers to do more on the networking level. It's forcing us to consider the entirety of the block of the network and the protocol as a whole, and it's sort of getting us closer to a world where the entire blockchain behavior is more formally specified. But again, we've been seeing attacks. So I would argue that the direction of moving from MEV boost, which is a form of protocol builder separation, but not an enshrined one, even though every single Ethereum consensus client implements it, is sort of a worse solution than enshrining PBS in some form. And we've already seen attacks on nodes and losses of funds and security incidents in the MEV boost system, and that would be better dealt with if it was part of the core protocol. Just kind of the other thing that I would observe is that, so in the spirit of modularity, app chain builders want a lot more control than traditional general purpose L1 builders ever had. L1 builders did not expect that they would be able to control the MEV for their applications. Tarun was just talking about this trade-off between sophisticated and unsophisticated users and sophisticated and unsophisticated application developers. Well, if you have a application-specific blockchain, you don't have to deal with that trade-off because the team is this application team is the team that built the blockchain. So if they're sophisticated, they will end up wanting probably a lot of control, and they'll want to have their own sort of fairness policy, and they'll want to be able to punish and slash and observe. And so as people are building toolkits for modular blockchains, people are building toolkits for L1s, I think we have an obligation to start building in more tooling into these systems to allow this kind of control to be expressed. And the fewer ad hoc systems that people have to build where there's no abstraction in the full node, the better things will be. So yes, the fundamental goal of modularism is lowering the cost of innovation. It will hopefully result in more shared infrastructure. There will be more libraries. There will be more binary pieces of software. There will be more examples of building systems where this block production and pre-consensus part of the network actually exists in the protocol, in the core software. As we have vendors for things like shared sequencing and intense mempools and execution, the more they can share components, it'll lower the cost of all of this. The sustainability of all of these pieces of infrastructure as the market fluctuates up and down should be a concern to everyone, and is a big part of the long-term stability of the space. So that's it. Thank you very much.